In the last video, we introduced logarithms. In this video, we're going to look at laws of logarithms. So there are three specific laws for logarithms. They're called the product law, the quotient law, and the power law. And they're stated in this box over here. So if you have a log base of something of x times y, you can separate your logarithms through addition, so that you would have log base of that something x plus log base of that something y. And then for quotient law, you can separate the inside of your logarithm, if you have division, into two separate terms of logarithms through subtraction. Then for your power law, your k power can become a coefficient or a constant that you would throw at the front of your logarithm, so you can multiply by that k instead. So we're going to use these rules and go through the different examples of utilizing the product, quotient, and the power law. So for example 1, we have log 50 minus log 25. Remember that if there is no base indicated there, we assume that is base 10. And we're trying to simplify this log into one logarithm. And we're going to look at our three different laws and see which one is applicable. Because we have a minus between the two logs, we're going to use our quotient law, because log x minus log y is log of x divided by y. So we're going to use our quotient law here. And it's going to be the first inside term divided by the second inside term. So that's 50 divided by 25. And I'm going to simplify that. 50 divided by 25 is 2. So log 50 minus log 25 is the same thing as saying log 2. Now for the next one, we're going to use our product law here because we have a plus in between the two logarithms. And we're going to combine it through multiplication. So this is log 5 times 12. And then we'll simplify the 5 times 12, which is 60. So then log 5 plus log 12 is the same thing as saying log 60. For our next one, we're going to use our power law. Our k value is 3 in this case. That's in front of our log 4. So I can make that 3 and put it back with the 4, so it becomes a power. Be log 4 to the power of 3, and then we can simplify 4 to the power of 3, which is 64. So 3 log 4 is the same thing as saying log 64. For our next example, this is a two-part type of question. I'm going to focus on the specific term first, one term at a time, and then I'll combine it after. So here I can see that I have a power law that I can utilize by putting this 2 back in with the x. So it becomes log x squared minus log y. And then I can use our quotient law because we have a minus in between the two terms of logs. So that is going to be log x squared divided by y. So notice here I use the power law first, and then I will use our quotient law. Once you get a lot of practice, you don't even need to separate it into 2 steps. You could just do it all in one, and that is completely fine as well. Okay, moving on to E. Again, I'm going to do each single term first by using the power law, and then I'll combine it afterwards. So using our power law, I'm going to bring the half back with the x as an exponent. So this is log x to the half minus, bring the 3 with the y, so log y to the power of 3, and then plus log z to the power of 2. Okay, now we can combine our logarithm using our product and quotient law. So be careful about this. If you see a minus in front of your log, this will be on the bottom of your quotient, If you see a plus in front of your log, then you can write that at the top of your quotient because that is multiplication. So then we're going to have log the x to the power of a half and z squared is going to be in our numerator, and that is because they are both a positive log. There's a minus, an invisible plus here in front of your log x to the power of a half. And then because we have a negative in front of our log y to the power 3, we can put that on the bottom. So this would be our final answer. And then lastly, for example F, this only works when you have the same base. So if you looked at examples A through E, we had the same base of 10 for our logs. Here we have a base of 4, which is fine. But here, this is not even a logarithm, it's just a number 2. So what we can do is rewrite 2 in terms of log base 4. Well, if I want to do that, remember from the last lesson how we're going to read this out is 4 to the power of what gives us 2. Or in other words, 4 to the power of 2, because that was our answer here. And then we can simplify this and solve for what that would be. So in other words, we have log base 4 of 16 plus log base 4 of 3. And because we have an addition sign between our two logarithms, we can combine them through multiplication. So that's 16 times 3, which is log base 4 of 48. And we're just going to leave it like that. So the important thing to note before I move on to the next question is, remember this was your answer and it's an exponent, which is why I put that in there. Okay, I want you to try the next two on your own, and then when you're ready, please press play for the full solution. Okay, so for this first example, we can utilize our power law here first, which becomes log 2 to the power of 2, which is also 4 if you want to simplify that. And then lastly, I'm going to combine everything. Remember, since we have a negative, this negative is going to be the bottom of our quotient, so the 2 to the power 2 is going to be on the bottom of our quotient, and this 9 and the 8 will be at the top because they're multiplied with each other using our product law. And then we can simplify this. So 8 divided by 4 is just 2, so 9 times 2 is 18. For our second example, we are going to again use our product law first. And then we'll combine it together using our quotient and power law. So our x and y squared are going to be in the numerator, the top of the quotient, and the z to the power 4 is going to be at the bottom because we have this negative in the front. So you have log of x y squared all over z to the power 4. Moving on to the next example, we are going to expand logarithms now, so we're going to do the other way around. So I'm just going to separate them first using our product law. I'm going to split this a squared and the c because they're multiplying by each other right now. So with our power law, this is log a squared plus log c. And then I'm going to use the power law and bring the 2 in front of our log. So 2 log a coming from our power law plus log c. For the next one, I'm going to use our power law, our product law, and our quotient law, these three together. And I'm just going to use our quotient law first and do things one at a time. So this will be log a squared. And because we have a division, we're going to use our quotient law. So it becomes minus of the entire denominator. We're not done here. There's still a lot that we can still try to simplify or expand it. So for log a to the power 2, I can use our power law and bring the 2 down. And then for our next term, I can actually separate this log b c to power 3 because this is multiplication in here. So I can use our product law, which becomes log b plus log c cubed. And then I'm going to distribute my negative. One more thing I need to do, I'm going to bring down the 3 in front of log c because that is part of our power law. And then that is our final answer. Could you have done this all in one step? Certainly you definitely can. I just broke it down into a couple of steps so you know exactly what laws I'm using and what I'm doing. So go ahead and try the next one on your own. It's completely fine if you want to do it all in one step if you understand right away. If not, you are free to break it down into smaller steps. And then when you're ready, press play for the solution. Alright, so for this try it yourself, I am just going to do this all in one shot so you kind of get an idea of how I would even do that if you don't know. So looking at our numerator, I know that I'm going to separate them using our product law. So I'm going to get log a squared plus log b to power 3. And because we have powers, I can also use our power law at the same time. Okay, so we have log 2 log a for the very first part of it, plus, because we're multiplying this a squared and b to the power of 1/3. And then we have this 1/3, so I'm going to move this to the front because this is an exponent. And then lastly, we have divide by that c. So I'm going to use our quotient law. It becomes a minus log c. And that would be our final answer. I did everything in one shot here. Again, if you're more comfortable doing it into multiple steps first, then you are welcome to do that. Moving on to the last type of example, which is evaluating logs. So you can try to evaluate this as is by looking at it. I can guarantee it's going to be much more difficult that way. What you can do is try to compress your logs into one single logarithm and then evaluate at the very end. So this is what we're going to do then. By looking at this first term, I'm going to bring this 2 with a 6 by using our power law. And simplify that. And because we have the same base of 2, I can combine these 2 logs together. And because we have a minus between those 2 log terms, we are going to use the quotient law. So that's log base 2 of 36 divided by 9, which is 4. And now we're going to ask ourselves 2 to the power of what will give us 4? And we know that 2 to the power of 2 will give us 4. So your final answer is just 2. Again, it's really important to note that you must have the same base to combine or expand logs. Okay, so we had the same base of 2 here, which is why we can use those rules. If we had different bases, then you cannot use those rules at all. Okay, moving on to the next example, we have a base of 9 throughout, so that means we can combine our logs. And I'm going to do that. So we have a plus in between their 2 logs, which means we're going to multiply them together. that's 2 times 6 to the power of 3, because this 3 can go with the 6 using our power law. And then we have a minus, which means it'll be on the bottom of our division. And this 4 can go with the 2, so that's 2 to the power of 4. Now, I'm not going to multiply everything and then divide everything. That's way too much work. What I can do instead to make this semi more simple is I am going to rewrite this into powers of 6 and to powers of 2. So it's going to look like this. So 6 to the power of 3 is the same thing as saying 6 times 6 times 6. And then 2 to the power of 4 is the same thing as saying 2 times 2 times 2 times 2. And I'm going to simplify it this way, and you're going to see why it's a lot easier. Well, 2 divided by 2, that's just 1, so that cancels out. And then 6 divided by 2 is 3. 6 divided by 2 is 3. 6 divided by 2 is 3. So what I'm actually going to calculate here is log base 9 of 3 times 3 times 3, which is 27. Okay, and then if you think about 9 to the power of what gives us 27, there is not a very specific number, like a whole number that will give us that. So I'm going to change this into an exponential form. 9 to the power of what gives us 27? This should look like a question that we've done before, and we can solve this by changing it so it has the same base. So I'm going to change this 9 into a base of 3. So that's 3 squared to the power of x, and that's 3 times 3. Now that we have the same base, I can get rid of the base and just focus on the exponent. So that's 2x is equal to 3. X is equal to 3 over 2. And that is our final answer to this one over here. So 3 over 2 is our final answer. All right, so you can try the next one on your own. I definitely suggest you do the similar method as I've done in example 3b. So go ahead and do that. And then when you're ready, please press play for the final solution. All right, so here is the try it yourself solution. I'm going to combine my logarithm, and I can because we have a base of 9 in each of our terms. So for the first one, we have log base 9 of 6 to the power of 2. And then this minus means that it's going to be at the bottom of a fraction. And this is going to be 4 to the power of 3. And because we have a plus, it's going to be in the numerator. The 2 will go with the 12, so that's 12 to the power of 2. And then now I'm going to rewrite this as multiplication. So 6 times 6 is the same thing as 6 squared. 12 times 12 is the same thing as saying 12 squared. And then we have 4 times 4 times 4. Now I'm going to simplify as much as I can here. So I know that 12 divided by 4 is 3. And then we can just simplify maybe one of these things. So I can replace this as 3 over 2, because that's the same thing as 6 divided by 4. I could also replace this here as 3 when I do 6 divided by 2. So really I'm going to have log base 9 of 3 to the power of 4. 3 to the power of 4 is 81. And I know that 9 to the power of 2 gives us 81. So our final answer is 2.